Hi, my name is Degerhan Deger. Today I am here with my team, Brad, Emre, and Brian, and we are going to talk about our project for Zimmer R&D. Before we start, I would like to give you an overview of our presentation. We will start with an introduction of the company, the background information for the project and their statement of need. Then we are going to move on to our approach, project costs and timeline. And we're going to end with our final proposal, the limitations of our project and how we can improve them. Lastly, there will be a question and answer session. So Zimmer is an international medical device company. They are located in Warsaw, Indiana, and they currently employ 10,000 employees worldwide. Their mission is to relieve joint pain by their personalized solutions on joint replacement. The company is interested in using additive manufacturing methods to improve their manufacturing capabilities and implications of their products. By switching to additive manufacturing, the company will be able to create personalized joints for the patients, guide less trained surgeons on their surgeries, save on production costs, and enable less invasive surgeries for the patients. Currently, Zimmer owns different 3D printing machines across different sites. However, the company relies on 3D printing freeware to print their designs. In order to maximize the business potential of their additive manufacturing capabilities, the company has requested us to provide a recommendation with a 3D printing software for Zimmer R&D. Right now, Brad will be talking about our approach.
All right, so to start off, Zimmer gave us NetFab and Within, two softwares that they knew they wanted researched. So they also wanted us to add one, two, maybe three others to our whole process. So we talked with some experts and research on the internet and came up with SolidWorks, who they're currently using as a free demo, Magix, and we also added AutoCAD because they're big in modeling. But after a little while, we found out AutoCAD's customer service as well as limited user friendliness and functionality, we dropped them from the process. So after looking through our project description, talking amongst ourselves, and looking at some software selection literature, we came up with a set of criteria that we felt were important in selecting a software. So we sent this to Zimmer for them to add or subtract anything they felt was needed or not needed, and also to come up with a ranking system of importance. They sent this back to us with a set of criteria that were yes, no, binary decisions like go or no go, and another set of around 15 or so criteria that they had ranked from most important to least important. And we, after reviewing this, we came up with a system to rank them in importance from 1, 2, 3, 4 stars being the most important. We then separated the criteria into 4 groups, which each member of our team took a set and personally researched them through the web, through customer reviews, through through emails and conference calls. And after we got this information, we kind of had a good idea of how we wanted to come up with a ranking system. Then we talked with our cluster leader, and after consulting with him, we came up with AHP. Go to the next slide.
So with the help of the client, for the first set of criteria, we decided to do a yes or no analysis, and we developed a list of 6 criteria to understand whether the selected software meets the mandatory requirements of the client. The table here reflects the analysis for each software. Usability means the ease of use when creating a 3D model of a medical device. For functionality, we research whether the software can be used as a tool to make medical devices. For 3D printing, the most crucial file format is an STL file because unless you have this file, you cannot print anything from your 3D printer. The client specified their use to be their applications to be with porous metals, so we basically searched for this application specifically, and the client also specified they want the software to be working on Windows operating system. In addition, we searched for free trial availability to enable the client when making a decision amongst the software. All of the selected software for analysis met the requirements of the client except for AutoCAD. We found out AutoCAD is intended for making architectural models most of the time, and the software is not user-friendly and doesn't provide freedom, which is to say customization, when designing complex models. So with the feedback of the client, we decided to drop AutoCAD from the project. And now,
So
going back to
when we
that.
decided with AHP, it's an analytical hierarchy process, which gives us a way to numerically compare our different criteria amongst each other and amongst the companies, which would not be numerical in itself without this process. So it comes up with a finite, tangible answer that you can see that one product is better than the other. So this worked perfectly for our situation. So in doing this, we had the importance of our criteria set as a 1, 2, 3, 4 star system. The items with a 4-star we ranked in our matrix as 3 times as more important as one with 3 stars, 6 times as ones with 2, 9 times as those with 1, as well as the 3 stars were 3 times as important as 2, and vice versa all the way down the line. So we gave these a ranking in our HP as a 1, 3, 6, 9. And we put this into a matrix and solved for the eigenvalues. Those eigenvalues were the overall importance of each criteria amongst each other. And then after that, we took each criteria in itself and compared that criteria amongst every software, and we put that into a matrix and came up with an eigenvalues for that as well, for the overall strength each company has in that area. And we multiplied each criteria's importance to each company's strength in that area and added all of those values up to come with a final answer for every single software.
So now we're going to show you our tool for AHP analysis, and Brian will be running you through the process.
Alright, so we started out by making a hierarchy tree, which we started here with our goal to recommend the best 3D printing software to Zimmer. From our goal, we came up with our criteria, which is in the red here, and from each criteria we go down to our alternatives. To get the values, we started with our criteria matrix of pairwise comparisons, which you can see we have all of our criteria horizontally and vertically, and each with comparison according to how important they are to each other. From there, we squared the matrix and found the eigenvalues here. We squared it again just to check the accuracy of the matrix. And since we compared this row of eigenvalues to this one, and there's very little difference, we decided to keep the second column of eigenvalues to use for our specific weights for each criteria. From there, we went on to the alternative comparisons for each software. So up here we have each alternative compared to cost, and so on for each of the different alternatives or each of the different criteria. We also squared those matrices and found their eigenvalues as well, which came out to be our final weights for the alternatives. From there, we came up with these two matrices here, this one being the alternatives compared to criteria, and this one being just the weight of each criteria. To find the benefit of each of the alternatives, we did some matrix multiplication between the weights and each alternative to come up with the benefit. And SolidWorks is the clear winner here, being a 0.3 over NetFab's 0.26. And from there, we were able to create a cost-benefit chart from the startup costs and the yearly costs. So our startup costs versus benefit, Emery will talk about that.
So in the startup cost versus benefit graph, we can see that NetFab dominates within Lab and Magix since it has higher benefits and lower costs. But here, there's a challenge between SolidWorks and NetFab, since SolidWorks has higher benefit but also higher cost. So if we move to the next graph, yearly cost versus benefit graph, we can see the same case here. NetFab dominates within and Magix, but the competition between NetFab and SolidWorks decrease since SolidWorks has more benefit while yearly costs come closer to each other. From here, we'll go to the PowerPoint again.
No. Before we move on, I'd like to show you what's the greatest thing or what makes our software cool. So whenever you change a value anywhere within this tool, let's say we change this to 5 and make this 7, change it the way we like it, and we'll see that the final values that we get in the end will change. So right now, before NetFab had a benefit of 0.26, but right now it has 0.25. For SolidWorks, it used to be 0.30, but right now it's 0.29, and we do display the changed values on our graphs also. So this is basically a tool that can be used in the future. And now, going back to the PowerPoint, Emre will be carrying on with our project timeline.
So for the project proposal, we first met with our client in Warsaw, Indiana at their headquarters to discuss the scope of the project, what they want from us to achieve. So for the developing solution method, we researched framework for software selection, we prepared and ranked criteria, and after that we got client feedback on criteria in order to finalize criteria based on the adjustments that Zimmer made to their preferences. We investigated multi-criteria decision methodologies such as benchmarking, SWOT, and AHP analysis. We discussed our approach with account executive and client. We selected and developed AHP analysis since it was the most suitable one for us. For collecting software data, we called software companies, interviewed engineers and 3D designers. One of our team members, Degger, went to 3D printing conventions. Also, we gathered information from Purdue 3D Printing Club. And as we can see from the Gantt chart, the most time-consuming part was calling software companies and interviewing engineers and 3D designers. So as a conclusion from our analysis, the best option among the four is SolidWorks. In this project, we had some limitations about some information from SolidWorks because they didn't want to give some information due to the lack of information we could give them about Zimmer. So it was difficult to add or remove criterion from AHP, and there's a large number of pairwise comparisons in AHP, which makes it difficult. For the final proposal, if we could obtain better information from SolidWorks, the analysis would be better, and also including additional software could make the analysis more vague and better. Thank you.
When you change those values in the matrix, they didn't make sense.